So let us see 23. Given that a function is a x squared plus 1 over 5, this is a quadratic. Alright, this is a quadratic, this is not a rational. Rational, it should be a x at the denominator part. So for the first, they say find the f inverse. Find the f inverse. So you have to be careful that our quadratic, we got the condition here. They're not taking all the quadratic. So this quadratic is like this. X squared, it should be x squared over 5 plus 1 over 5. So it will be like this. So this quadratic only taking this part, x greater than 0. So it not taking this left hand side part. That's why this quadratic can be inverse. So they ask us to find the first task is find our f inverse. So we will start our task, f inverse, let it equal to y. And then we inverse it become f, domain become range, range become domain. So y and x exchange the place. And then we substitute our y into our function. Substitute our y into the function. So where this is y, it will become y squared plus 1 over 5. Then we find out our y. Multiply 5 and then move the 1, it will become 5x minus 1, and then move our square. When you want to move our square, it will have positive, negative square root. So we have to be careful here, because quadratic originally is not one-to-one function. So that's why it has two answers here. It has two answers here. It got two y value here. So when we see here, y, when we move our square, we got positive, negative, two answer. And this y should be my f inverse. So we have to see only one part is taken, because the question already filter for us. They said they want the right hand side part, because x greater than 0 means our part will be getting more than 0. Our part will getting positive, positive, and more positive. So positive means they want right hand side part. So from here, from the condition that the question give us, they said we can say that condition is given here, x greater than 0. So therefore our y only accept the positive answer, because they are taking the right hand side part. So finally, we can find our f inverse is square root x plus square root x minus 1, square root 5x minus 1. So taking positive part. Why positive part? Because the domain tells us x greater than 0 is a right hand side part. So right hand side part is positive part. So by using this, hence, so by using our f inverse here, hence, they say if the composite function f gx is equal to c, please show that we have a function gx equals to e3x minus 1. Okay, so from the given information, f gx equals to 1 over 5, and then e to 3x minus 1 plus 1. So this is the given function. How we do here, because we want to find out gx, we cannot use this answer. We have to show until this answer. So we will substitute our gx into our fx. We don't have any gx, we need to find. So we substitute our gx into our fx. So we will get gx squared plus 1 over 5. Okay, so from here we can simplify. 5, go there, multiply by 5, simplify, finish, and then g squared x equals to, move the 1 to the right hand side, it becomes minus 1, so also can be simplified. Therefore, lastly, we only get g squared x equals to e to 3x minus 1. So from here, our square, we have our square here, when we move it to the right hand side, we can cancel the square, and we only have e to the power of 3 minus 1. So this is how we shown our gx. Okay, so catat markah. For the first one, here, concept of inverse function, and then get to the answer. And then concept of composite function, simplify until we get g squared, and remove our square, we manage to prove our function of g. Then we continue. Find our gf2. So means that we are going to substitute 2 into our function f. So what is our function f just now? So substitute 2 here. 2 squared plus 1 over 5. And then you get a 1 here. Then you substitute 1 into your gx. 3 to the power of e to the power of 3 times 1 minus 1. So e to the power of 2. So they said 3 decimal. We follow the question 3 decimal. So of course, we also can put our value of 2. We have 2. We have fgx is not gfx, so I have to substitute 1 by 1. So this is only the way. So that will be our first substitution of value of 2 into function fx. Then continue, substitute the value of 1 into the gx, and get the answer in 3 decimal place. And then we go for question C. Assuming the domain for gx is greater than 0, x greater than 0 means positive. Our gx is positive right now. Okay, so our gx is taking the positive part, it's not taking the whole function, it's just taking the positive part, x greater than 0, one part only. They ask us to determine the g inverse. So we will start g inverse x equals to y. So gy equals to x. So what is our gy? We can substitute into our function gx here. 3y minus 1 e 3y minus 1. So log the base e will become ln. To the opposite, find our y. So all I can write dy by 3 for this whole function. So this will be our g inverse. And then state with domains and range. So when I want to find the domain of g inverse, I have to refer to the range of our function. And when I want to find the range of the g inverse, I have to refer to my domain. The domain is, the domain of g here is 0 to infinity. So, okay, so range of f inverse, range of g inverse, refer domain. Domain of g inverse, refer range. So now I need to refer the range here. So since our graph here is not a completely full graph, already become one part, so I will draw the graph in order for us to see the range. For exponential part, e to the power of positive. So its original graph will be like this. That is asymptote is y equals to 0. This is our original graph. Because e to the power of x is positive, this is our original graph. This is our gx. E 3x minus 1. And because of the question's condition, it made this graph to become one part only. X greater than 0 means I want this part only. When I want this part, means this we're not in consider anymore. We're only taking this part only. So therefore, you can see my domain of the function is 0 to infinity. Domain is talking about x. Range, we're talking about y. Okay, so domain 0 to infinity. So domain G will be equals to range of G inverse. So when you want to find the domain of G inverse, we will find range. We will find this range. So when you look at the range, means we look at the y. Look at the y. So the y from the bottom here, no more graph. No more graph. The starting point we have graph is here. So our range will be start here. Our range of this function will be start here. So what is the value of this? When x equals to 0, this is e to the power of negative 1. When x equals to 0, we substitute our y coordinate there, it will be e to the power of negative 1. So equivalent to 0.3678. So we can see our range here. Look at the y here, no graph, so no range. The minimum range starting point is 0.367 and we got graph going upward. We still got graph going upwards. So our range here will be starting 0.3678 going infinity. And I use close bracket because of what? Because this point is included. When x equals to 0, this point is included. So means that this value of y coordinate also included. Seven, eight, nine. So I have to rounding. I have to round off because 8, 7. So 9. So give more decimal. So maka dia akan jatuh kepada find the inverse here, concept and answer. Then for this 1 marks. Domain G inverse refer range. Range G inverse refer domain G. Okay.